My name is Grace Bennett. I work at Middle School 88 and I teach 7th grade STEM. We start the year off with an introduction to the engineering design cycle. Most students are not familiar with it, or they might have heard of engineering, but they're not really comfortable with the actual process itself. So the first introductory projects are very small and just get them through the idea of cycling through multiple iterations and refining and constantly trying to improve a final product. As we get towards the end of the year, the students are more comfortable with the engineering design cycle. It's more like second nature at that point. And then it's when the projects themselves start incorporating more scientific topics.
One of the biggest challenges facing teachers in incorporating the engineering design process into their curriculum and their teaching is they feeling like it's beyond their scope. The engineering design process is just a framework for solving problems creatively. And once you can internalize that, it's much less intimidating. I really see the engineering design process as a framework for creatively solving problems. And it could be anything from like designing solutions that are global, like redesigning the Gowanus waterfront to make it resilient to climate change impacts, or something smaller scale like the water fountains and our floor aren't working.
This project was slightly different than I normally do. This project was mostly to be, to tie up the end of the year and to have like a class competition, so putting their engineering skills to use in sort of a fun and competitive way. It was more just like, here's a challenge, and can you use your skills as an engineer to tackle this challenge? And we wanted to see who could make the fastest submersible. I like reinforcing the ideas of variables, where students get to actually manipulate the variables as they're learning those terms. There's constantly misconceptions around which variable is which, so I thought this would be a nice way for them to apply those terms and reinforce that vocabulary so that as they're progressing through 8th grade and then in high school, they'd have a stronger understanding. Leading up until today, students were doing background research and they were reading various articles about the different effects that variables might have. So they were learning about streamlining, they were learning about what a propeller is and how a propeller works and forces and motion. So I wanted to make sure they had the background to make good decisions that would help them in their process. So students did background research and then they laid out their initial designs. And before the building process actually started, they got to see videos from submersibles so that they could see what they're actually used for and why submersibles are important. And then they built the submersible, tested them out, and then needed to come back and rebuild.
What I've been doing is I've been spinning the rubber band at least 100 times so we could have the propeller push the submersible further so we could get a good score, like around 33, 34. So
At the beginning of class, students were sharing their data and their models. They were reminding each other of which variables they changed and what the outcomes were, so what their average speeds were. We were taking a look to see if the trials between averages were similar or not, so that students could actually ask themselves if they believed the data, if the data was reliable. The idea is that students are going to be able to change whatever they want, but there needs to be some reason for it. And the reason should be the data from experiments, whether it was their group or another group. So then students got to, once they brainstormed and decided what they wanted to change, they got to build their submersibles and then test them out to see if those changes actually worked. We're going to be sharing out our data, and we're going to be entering into a redesign cycle.